Today's topic is inverse standard normal distribution function. This is the curve of the standard normal distribution in which you can see that the mean of the standard normal distribution lies at 0, and 0 is in the center of the curve. The peak of the curve exists at the mean, and mean is 0. Left hand side always having the negative values, and the right side having positive values. This is a scale of the standard normal variate z. So at any point, for example, this point is here. If this point is here, then the probability starting from minus infinity to the specific point, for example, this one, starting from minus infinity to this point, this probability is always is phi of z, this phi of z. So probability z less than small z, this point is called small z. So in our case, small z is 1. So probability z less than small z, which is 1, is always phi of z. And if we take this probability is given because we are using inverse standard normal distribution function, in which probability the shaded area, which is on the left side, always on the left side, because phi is the area which starts from minus infinity to that point. So this is our shaded area, and this shaded area is equal to phi of z. So this probability phi of z is given if this area is phi of z is small p. If this is given, then you can find your z. This point is unknown, this is unknown, and you have to find this point, and this point in our case is small z. So this point is unknown and p is given, this p is given, and you have to find this p using phi of z. Phi is on the left side. If it goes on the right side, so it will be phi minus 1. Whenever it is on the left side, it is positive. When it goes on the left side, so it would be phi inverse of p. So this is actually inverse use of our table, in which probability is given, this is given, and you have to find z. This z is unknown, and you have to find this value. Okay, so this is the table which we would use in inversely okay, where is this is, yes, this is actually the table in which quantiles of the standard normal distributions, this is the title of the table, and the page number is it's a 10A table, page number is 295. So we will consult, we will search our probabilities here, because you can see that probability is given here. You will locate your probability in column and upper captions in a row. So probabilities are given here, and you will locate the z, which is given in the center of the table, and you will see that the tabulated value zp is equal to phi inverse of p. So you should know that phi inverse, whenever you have to find the value of phi inverse, you will see this table. Okay, now come to the topic from your book, in which the topic is quantiles of the standard normal distribution. Okay, first I will vanish all the clear all the drawings so that we can read. Okay, quantiles of the standard normal distribution. You know that probability always lies between 0 and 1. So let P from 0 to 1, then the pth quantile. At that specific point, you can have the value of your z. This is your specific point. For example, this one is minus infinity and zp is here. So up to this point, the probability is small p. Okay, this small p is the probability starting from minus infinity to this point, and this zp, which is on the z line, this value is unknown. This is actually zp is unknown. So I am placing here a question mark. So probability is zp less than small p, and zp is equal to phi inverse of p, as we have seen in the presentation. Now, for example, this probability is given as 0.95. So whole shaded area is, this shaded area is 0.95. All this area is equal to, for example, in our case, if it is equal to 0.95, then it's z 0.95. So we will write in small subscript 0.95, okay, or simple small z. But specifically, you have to mention your probability here z 0.95. So it's 0.95 in 95th percentile. It's a 95th percentile at this point. So there are 100 percentiles. So that's why it is called as quantiles. There are 4 quartiles in the distribution. There are 10 deciles in the distribution, and there are 100 percentiles in the distribution. So ZP95 shows that it is also called as 95th percentile. So this is given here. This shaded area is actually 0.95. This shaded area is 0.95, and you have to find your percentile ZP at this position. Probability is given and ZP is unknown. So ZP, Z 0.95 retain on the left side and phi comes on the right side. Here it is positive. You can see that your look, phi is here positive, but it comes on the right side. Its power is minus 1. So it's a inverse of 0.95, and Z 0.95 still retain on the left hand side. So always you have to find a specific value, specific point on Z scale by phi inverse of the probability, phi inverse of the P. We will locate our value in table 10a. It would be 1.645. Now come to the example 10.5. In this example, look, it's 75th percentile of the distribution Z, and you have to find the lower and upper quartiles. As I told you that this distribution have three Q1 first quartile, Q2 always in the center and it is equal to 0. So we don't need to find second quartile, and third quartile is here, and below third quartile you know that 75% area lies between under the point third quartile, 25th percent area below the first quartile, and 50% area below the second quartile. So we have to find upper and lower. It means Q1 and Q3 are required, and interquartile range, the difference which depends on the quartiles. Firstly, we will find the quartiles, then we will automatically find the interquartile range and the quartile deviation also. And there is one more thing, which is 75th percentile. So you have to find P 0.70 value. Okay, Z 0.70. So P is 0.70 given. Come to the solution. We will see in our solution. Okay, look, first is this is quartile 1. So you know the first quartile below this point, 25th percent area, 0.25 area below this point. So required is Z 0.25. So we will write it probability Z less than. Always write less than because it starts from minus infinity. Here it starts from minus infinity. Here it starts from minus infinity. So always write probability Z less than, because probability less Z less than is replaced by phi. So probability Z less than 0.25. It is also written by as phi of Z 0.25, and probability is given as 0.25, 0.25, and phi comes on the right side, so phi inverse. Whenever this is written phi inverse of some value, we will come to the table, and table gives us this value. We will also locate the value from the table, but come to the next quartile first. It's a P 0.75, third quartile, which is probability is given as 0.75, and its area you can see it's here. Okay, and probability is Z less than Z 0.75 is replaced by capital phi of 0.75. I told you that whenever area is given on the below the point, it is less than sign, and less than sign probability Z less than sign will be replaced by capital phi. So we will write it as capital phi. If there is greater than sign, we cannot write it as phi of z. We will firstly convert greater than sign into the less than sign by taking it 1 minus the same value. Then the area will be less than, and then that value of z is replaced by phi of z. मैं आपसे ये कह रही हूँ कि ये z जो है वो लेस देन साइन होगा तो आप इसको फाई लिख सकते हैं. अगर ये ग्रेटर होगा तो पहले हमें उसे लेस में कन्वर्ट करना होगा. लेस में कन्वर्ट करने के लिए आपको पता है कि z greater than specific point is equal to 1 minus probability z less than that point. तो वो लेस वाला में कन्वर्ट हो जाएगा. जब लेस में कन्वर्ट हो जाएगा तो हम उसको 5 लिख लेंगे, लेकिन यहाँ आएगा 1 minus 5 in that case. Okay, so always write it as phi of 0.75, and its probability is 0.75, and phi comes on the right side, it's phi inverse, and whenever phi inverse is given, we will see our value in the table. Now come to the table. This is table. Probability is here in the column. You can see 0.75 in this, but it's not in this page, on this page. So come to the next page. And this last, I think in the last row, we will have the value of, no, this is 0.74. Come to the next page. Okay, on the next page, the first value is 0.75 against the 0. So it's 0.6745. Okay, so we will write it here in our book. We will see the answer is okay, 0.6745. Okay, so directly we will locate this value in the table and write the answer here. Interquartile range is the difference between the third quartile and the first quartile, and it gives you 1.349. And quartile division, whenever you divide interquartile range by 2, it is called quartile deviation. So the difference is this one, and you will divide it by 2. The answer is 0.6745. Okay. Next is the P 70th percentile. It means P probability is 0.70 given, and we will follow the same instructions and locate this value in the table and find our answer. Now this is the last topic of this portion of the normal distribution. Now I will discuss you something more important. Now come to the theorem which will be used in our next slides. theorem used in inverse standard normal distribution. Phi of minus a is always obtained by 1 minus phi of a. Okay. And phi of z greater than a is equal to phi of minus a. As I told you that it's a greater than sign. And if it is greater than sign, okay, we will take this figure on the next page also here. Okay, if we look at the 2 points here on the number line, and these 2 points are, for example, one point is on the left tail and one point on the same height on the right tail. Okay, this is called the right point is called as a. For example, this is a, and the same point on the left side is denoted by minus a. I'm writing below so that you can easily read it. It's minus a. Both points are equidistant from the center. The distance between these two lines are same. So the area, the shaded area on the both edges are also same. For example, this is the area on the left tail. We will say this shaded area is phi of, this shaded area is phi of minus a, capital phi of minus a. Okay, and also this one. And this area on the right tail is not phi of plus a. This shaded area is 1 minus phi of a. We have studied this topic that this area is called phi of, as you can see, both shaded areas are of same length, same shaded areas. So this would be equal to phi of minus a. And this is obviously, again, this is also phi of minus a. Both areas are phi of minus a. That's why this is capital phi. That's why I'm trying to write it as capital phi. Don't confuse it with small phi. Small phi is always used to denote the PDF of standard normal distribution function. So in capital phi is the shaded area, the probability. Okay. So probability z greater than a is this one. This is our probability z greater than or greater than a, both are same. This is probability greater than a. And from figure we came to know that both shaded areas are equal. That's why probability z greater than a can be obtained by phi of minus a, or directly we know that this shaded area is equal to 1 minus phi of a. This probability is also equal to 1 minus phi of a. So both ways, this is capital phi of a. This is phi of a. Okay. And third is probability modulus z greater than a is 2 phi inverse of phi of a minus a. We know that the probability greater than this point is phi of minus a, and modulus z shows, this modulus z shows that area on the right tail and area on the left tail both are included. Okay, whenever modulus z is given, it means it's plus a and minus a both. So we will multiply this area phi of minus a by 2 because both areas are same. So if this is understood, if you know that phi of z greater than a is equal to phi of minus a, then modulus of this one is twice of this one. Okay, but if we will talk about the last one, in which probability z less than a, less than sign gives you the area between 2 points. Uh, Again, this is, for example, minus a, and this is, for example, plus a. The shaded area is now, in this case, is between 2 points A to minus A. This is our now shaded area. I should not use arrow, but okay. So this shaded area on the left tail and this shaded area on the right tail. Both are included in this last fourth part. Okay, you can clear color in one direction also. It's up to you, but it looks good. Lighter tail is in this way. Okay, probability z less than a means the area between this point is minus a, and this point is plus a. For example, I will write it here as this point is minus a and this point is a, and the shaded area is between these 2 points because here is the sign of less than. Whenever there is sign of less than, then you must be shade less than sign. I am highlighting this sign less than. So you should color or shade the area between these 2 points. This less than sign shows that area should be always in the center of the distribution, and which is equal to 2 phi of a minus 1. 2 phi of a is obtained in such a way that you know that phi, I'm choosing a different color, okay, red. Phi of a gives you the area from minus infinity to this point. This is the point where a exists. So phi of a is this area, and again if it is multiplied by 2, then it is this area is multiplied by 2, and you know the half area is this one, which is equal to 0.5, and this shaded area is included twice. Okay, 2 phi of a have this area 0.5, and 2 phi of a will have this area twice, this left side area twice, and 0.5 multiplied by 2, it's equal to 1. So we will subtract minus 1 from this area to get actually this one, to get uh, okay, to get this shaded area. Okay, this shaded area is actually, in our case, is required one. Okay, this shaded area is required, and whenever we are going to multiply by 2, then it's also twice, one from the right side, one from the left side. So first of all, 2, this one, 2 phi of a gives you the area, red line, and again red line, twice red line. It means this is the area added in this 2 phi of a twice. So we will subtracting 1 from it to exclude this area. If this area is excluded, and twice of this area is actually one for the this part and one for the this part. Okay, one for right side, one for the left side. Both area are included. Okay, this is a comparatively difficult theorem, but we will use these four axiom of the theorems, the four parts of the theorem in the questions involving inverse standard normal distribution, in which we will use table 10a. Now come to the next topic, which is very important, and points are to be remembered for doing the questions for the whole material we have studied right now up till now, in which probabilities are given. If okay, this one first, if z is given and ordinate is unknown, small phi of z is ordinate, and we can say it's PDF, or we can say it's the height of the specific height of the curve at specific point. So all three ways are okay. So phi of z is unknown and we have to find phi of z. Then we will consult 7a table. Okay, 7a table. This is on page, this is 9 table, this is 9, this is 7a. Okay, ordinates, clearly mention ordinates, small phi of z. You can confirm your required value from the caption of the table. Never use table with close eyes. हमेशा आपने टेबल यूज करते हुए देखना है कि कौन सा टेबल यूज कर रही है. Ordinate find करना है, then you will consult table 7a, and ordinates are mentioning here, and small phi of z is also there. If z is given, this point is z. If z is given, for example, this z is given, blue color z is given, the height is this one, which is written here as phi of z. This is phi of z. In our case, it's equal to 0.1200, for example, but this is the height. This height is called ordinate, this one, phi of z. And if this z is also given, and you have to find the area, capital phi of z. Small phi of z is the ordinate, capital phi of z is the area. This shaded area, blue lines shows that is the shaded area. This is denoted by capital phi of z. This is unknown. If this is unknown, then you will consult table number 9 and find the area, find the probability, find the phi of z. All three ways. You can write phi of z, z less than z, and p. All are same. So you can obtain your shaded area or probability from table number 9. And thirdly, which we have done today, in which small p is given, but z is unknown, then use table 10a. Look, this is the probability which is given. For example, this shaded area is given, and in our case, z is question mark, means this value is unknown. If this value is unknown, then you have to consult table 10a. Thank you so much. Now do the question from the exercise, and exercise having the question number 5, and this is 10a. So your homework is now to do the question related to this topic, which is question number 5, in which you can see probability is z less than a, and you have to find the value of a. And now in the next inshallah we will do the remaining questions. Thank you. Allah Hafiz.